So let's look at the agenda. Well, there are basically three scenarios that we're going to look at. The first one is, how do we manage large clusters? It has nothing to do with mod cluster, but you'll see that mod cluster helps in managing large clusters and a large and especially a varying number of clients, especially in clouds. The second scenario is rolling upgrades. How do you upgrade software or hardware without downtime? That's the second aspect we're going to look at. And the third aspect, and probably the most important aspect, is mod clusters' ability to dynamically add servers to a cluster and deploy web applications versus the static configuration of mod JK. So at the end of the 60 minutes, I hope to have everyone convinced that mod cluster is really better than mod JK and that everybody should switch to mod cluster as soon as possible. The context is clustered web applications. I'm going to run the demo basically showing a simple web application. Okay, so let's take a look at mod JK first. So typical setup of mod JK is you have a bunch of HTTP daemons on the left side. You do have a bunch of JBoss instances on the right side. And when I say JBoss instances here, it might as well be, these instances here might as well be Tomcat instances, or in mod JK speak, they're called workers. Okay, these workers basically form a cluster. So in this case, any session in this cluster that is modified will be replicated to all the other nodes in the cluster. So if you modify a session, for example, on this node here, then the replication will go to this node, this node, this node, and so on and so forth, to all the nodes in the cluster. And basically every node has the same session, or the same sessions, I should say, and when a node should fail, then the clients would be redirected to another node which has the same session. Okay, this is bad for various reasons. I'll talk about them a couple of slides down. All right, so let's take a look at the mod J configuration. As you can see, it basically consists of two files. One is called worker.properties, and that's basically defining the workers or the JBoss instances that are part of the cluster. And here we're defining, we're adding another instance called JBoss3, and we're basically adding the instance to a list as well. So mod JK actually knows that JBoss1, JBoss2, and JBoss3 are the nodes among which it should load balance. Okay, so basically add your hosts to worker.properties. If you add a new host, if you remove it from worker.properties again. Then we also have a second file called URI workermap.properties, and this basically defines what applications are hosted by JBoss 1, 2, and 3. In this case, we're adding a new web application called My New App. It's added to the load balancer, so any request to My New App will go to JBoss 1, JBoss 2, or JBoss 3 as defined up here. Okay, so this is very static. When you want to add a new JBoss instance, you have to modify worker.properties. When you want to add a new web app or remove it, you have to modify URI workermap.properties. There are basically two issues we're going to talk about in this talk in a little bit more detail. The first one is basically large clusters and rolling upgrades. How do we do that? How do we manage large clusters? How do we manage rolling upgrades? And then the second one is static configuration. How do we dynamically add a new JBoss instance or dynamically deploy or undeploy a web application? This is basically the value add of mod cluster over mod JK. And static configuration is not good in a cloud environment where the hosts are dynamically added or removed. Let's say you're expecting a spike around Christmas. You have a bookshop, and you expect a spike around Christmas, and so you want to add another 25 hosts. If you use ModJK, you would have to modify the work product properties file and the URI, the mapping file on 25 hosts. So this is very tedious. So you would have to add 25 hosts and all the applications that are on those hosts to on the Apache side. Let's focus on the first problem: large clusters rolling upgrades. So in my experience, most of the time, downtime is not caused by crashes, but by upgrades. You want to upgrade JBoss, for example, from 4.2 to 4.3, and the new release is binary backwards incompatible, then the restarted node won't be able to participate in the cluster. How's that? Let's say you change something in the binary format, and now the new node is started, but it cannot talk to the old nodes. Therefore, it cannot get the state, in this example, the sessions from the old nodes, and basically would form a singleton cluster. And that's not good, because that means we would eventually incur downtime because we have to shut down the entire cluster and restart it. And that's not very good. Then what causes incompatibilities? Applications can cause incompatibilities. Let's say if your application puts something into a session and then that something, that class is changed so that the serial version UID doesn't match anymore, then you wouldn't be able to exchange or basically pass a new instance of this data type to an old instance and vice versa. Database schema changes, that's a separate talk. That's a very difficult topic. If the entire cluster hangs off of a database or accesses the same database and the schema changes, then of course your host, the entire cluster will be host. So here there are ways to actually upgrade or basically schema migration in an online system, but that warrants another talk, and that's not that would burst the scope of this talk. What are issues with large flat clusters? Well, a problem, if you have a problem in a large cluster, the effect of the problem multiplies. So it can potentially affect many nodes. And one of the things that is a problem is state. So, for example, when we have 10 nodes and every node has a gigabyte of state, and you replicate the state to everybody else, then every node basically has to have 10 gigabytes of state, and that's very non-scalable. If you have 100 nodes, then everybody would have to have 100 gigs, and that doesn't scale at all. So total replication doesn't work for large clusters. Then also RPCs across the cluster. If you have an RPC, a remote procedure call across 1,000 nodes and 1 blocks, then you basically have to wait until a timeout kicks in or until you get the reply from this one node. So it's just economies of scale, but in a bad sense, one problem multiplies and has a ripple effect through the entire cluster. Then a large cluster always has problems with TCP. If you want to send one message to the cluster and you use IP multicasting, you basically send the message only once. But if you use TCP, TCP doesn't know this broadcast or multicast mode, then basically you have to send the message n-1 times. So if you want to send it to a cluster of 1,000 nodes, you send it to everybody else. So you send it 999 times. And that's very non-scalable. Even if you do parallelize the sending, the line between you and the switch, which would still be taxed by the communication from you to the entire cluster. So what's the solution? I'll first talk about ModJK domains, which is a solution to this problem, and that's not specific to Mod Cluster, but then show what Mod Cluster offers on top of ModJK domains. Okay, so what I suggest is divide and conquer. Instead of a 1,000 node cluster, a big, large, flat 1,000 node cluster, create 10 domains of 100 nodes each. And that's just an example. It could be 10 domains of 10 nodes to manage a cluster of 100. In this example, a domain is always also a cluster, but it doesn't need to be. That's just for the purpose of the example. We'll talk about this a little later. So what happens? HTTPD creates a new session S on a random node N in a random domain D. Okay, so basically creates a sticky session S somewhere on a node in a given domain. Then all the requests for the given session S go to N in this domain, and I'm assuming that sticky sessions are configured, of course. If N is shut down or crashes, then S is directed to another node within the same domain. So replication and load balancing happens only within a given domain. Changes to S are replicated only within D, and if there are no more nodes in D, S would be lost. So there's no replication between domains, and the domain in this case is a JBoss cluster, but it doesn't need to be. Let me show this in a picture, which shows it much better. So here we have a domain, we have 3 domains, A, B, and C, and we have 3 HTTP daemons, which take requests from clients and then basically pick a node in a given domain. Let's go through an example. Let's say a request comes in through the second Apache HTTP daemon, and it happens to hit domain A. It actually goes to the second node in domain A. Because the session is sticky, requests will always, no matter which HTTP daemon they hit, they will always, based on the JSession ID, go to the second node in domain A. Should the second node in domain A crash, then let's say, as an example, we're picking the third node in domain A. And again, the replication, the unit of replication is the entire domain. It's not between domains, but basically the entire domain. So should all the nodes in domain A crash, then the session is host, the data is basically lost. The next request for the same session would go, let's say, to domain C, to the first node, but since this node doesn't have the data of the first domain, it would simply be an empty new session. Okay, so the most important thing to note here is that the replication domain is always, or basically replication happens only within a domain. Therefore, we don't have the scalability problems I was alluding to earlier. Okay. Now, how do we do rolling upgrades? Well, what we do here is that an entire domain is upgraded, not an individual node. The steps would be you disable the entire domain, and you can do that through the /status application on ModJK. And I'll show you how to do this in ModCluster in about 20 minutes. So you disable the entire domain, which means HTTPD won't create new sessions on the disabled JBoss instances, but requests for existing sessions will still be forwarded to disabled workers. However, all new sessions are created on other domains. And when all the sessions of a given domain have expired, we can shut down all the workers, upgrade, and restart. So basically, when there are no more sessions in a given domain, we can simply shut down all the nodes and upgrade them and restart them, and then they would be served again by HTTPD. Now, what is important about this is that, is the last bullet item here, that different domains can actually have different software versions. If I go back one slide, then domain C could be running on JBoss 6, domain B could be running on JBoss 5, and domain A could be running on JBoss 4.2, except, of course, 4.2 doesn't have support for ModCluster. But all that is needed are basically those lines here, and that's a protocol called HAP. We'll take a look at this in the next slide. Basically, the HAP protocol doesn't change, It's actually an Apache protocol. It doesn't change. So as long as the protocol remains stable, we don't care what versions of the software we're actually running back here. As long, of course, as the individual nodes in a given domain are running on the same software. But between domains, we can have different software versions. How do we configure domains in ModJK? Well, it's actually very simple. We just add a keyword domain. In this example, JBoss1, actually, JBoss1 and JBoss2 run in domain A, and JBoss3 and JBoss4 run in domain B. So we have two domains containing two JBoss instances each. To start JBoss, we have to basically make sure that we separate the cluster traffic for A and B. In this case, we want to make sure that one domain equals to one cluster. And to do that, we basically say that node 1, JBoss1 and JBoss2 should run in cluster A, and JBoss3 and JBoss4 should run in cluster B. We also give these clusters different multicast addresses. So the first cluster, A, runs on 232.111, and the second one runs on 232.222. Different multicast addresses, JBoss1 and 2 use 7,500, and JBoss3 and 4 use 8,500. And we also give A and B different routes. We actually call the routes JBoss1, 2, 3, and 4. This here is not really needed if you use TCP. And in the demo, I'm actually using TCP because EC2 and most cloud providers don't allow multicasting. But basically, the domain configuration says we have two domains, two nodes each, and domain A is the same as cluster A, and domain B is the same as cluster B. Okay, so basically we have now solved our large cluster problem. We can basically apply a divide and conquer approach. But how about static configuration? And that's actually where ModCluster is going to come in. So the problem is basically when a worker is added or removed, so you want to add 20 new JBoss instances, we basically need to modify worker stop properties. When we add or remove web applications, then we need to modify URI worker method properties on all the HTTP servers. So in the example above, in the previous slide, we have 3 HTTP servers, so we would have to go to all 3 HTTP servers, SSH into them, or use cluster SSH or whatever, modify worker properties and URI worker method properties. This is tedious for large clusters, or if you have dynamically changing clouds, you just want to fire up your instances. They're supposed to find Apache instances and then register themselves. And this is exactly what ModCluster does. ModCluster works with almost no configuration on the HTTPD side. You'll see that in the demo. It works with HTTP 228 and higher, JBossAS 5. It ships with JBossAS 6, JBoss Web 221, and Tomcat 6 and 7. It is based not on ModJK, but on ModProxy. And the URL, I'm going to show this URL again at the end, is basically jboss.org/mod_cluster. So what does ModCluster provide? It basically provides 3 features. The first feature is that workers, in this case JBoss instances, register themselves with the HTTP servers. There is no need to modify worker stuff properties, and changes in a cluster topology are also sent to HTTPD. So basically, when a JBoss instance starts up, it needs to know where the HTTP servers are, and then basically it registers with the HTTP servers dynamically. When a node crashes or leaves, it'll also tell the HTTPD workers. Of course, when a node crashes, it won't be able to tell the HTTPD side, but somebody else in the cluster will actually take over and then tell the HTTP side that this node just crashed and that no more requests should be sent to this node. The second feature is that deployed web apps are automatically registered with HTTPD, and when you undeploy a web app, they're automatically unregistered. This is actually a very cool feature. Imagine you have 10 servers, and only 5 of them have an application X. In ModJK, you would have to basically there is no way that you can tell Apache that out of 10 workers, only 5 serve a given application X. So basically, ModJK wouldn't know about this and would just send requests to any of the 10 servers, and then you would basically get 404s because it doesn't find X. So the cool thing here is you don't need to modify URI worker method properties. I'm actually going to show in the demo by just undeploying a web application, you will see that it actually is unregistered and no more requests are sent to it. The third feature of Mod Cluster is dynamic load balancing based on actual load. I'm not going to talk about this in this talk in detail. So what it does is the workers or the JBoss instances can send load factors to HTTPD. So HTTPD can forward requests based on actual load. Now, what is load? Load can be CPU usage, number of bytes received, rolling average over the last 30 minutes or whatever. Connection tables, how many sessions you have. It can be anything. As a matter of fact, the load computation is completely pluggable. So to plug in a new load computation, you could actually come up with something that is specific to your application, and all you need to tell us is a number between 1 and 10, I believe. So when your application has some sort of load metrics, you can actually use that load metric and send it back to Apache HTTPD, and Apache would take that into account when it allocates new sessions. So for example, when the load is high on your given node, then it would not allocate any sessions on your node. All the load factors can be combined. You can say number of sessions is 40% in terms of importance. Number of connections in connection table is another 40%, and CPU time is maybe 20%. And all these factors decay over time. So this is a very cool feature. Unfortunately, I don't have time to talk about this, but go to jboss.org/modcluster and read up on it, or try it out yourself. All right, this is the architecture. It's basically the same as for mod proxy, except that there is a backlink or a back channel from the workers to HTTPD, as shown on the left side here. So on the right side, we have mod proxy HAP. And by the way, if you want to encrypt this, you could also use mod proxy HTTP to basically use HTTPS to send requests. So this is existing. This is nothing new. The new stuff is on the left side. We basically have a back channel here to tell HTTPD when a new application has been deployed or undeployed, or when a new worker was started or stopped. Also, we send load information from the workers to Apache. Now, don't worry about this back channel. This is just conceptual. You do not need a new port. So if your Apache runs on port 80, Mod Cluster will actually use port 80 as well. This is really just a conceptual picture. How does it look like in terms of configuration? I said there's minimal configuration on the HTTPD side. You need to load a bunch of modules. Obviously, if you don't need certain functionality, you don't need to load them. And basically on the here you define a listen port. So this is port 8000. My Apache instance, that's the demo, listens on port 8000. And I define a mod cluster manager handler, which allows me to look at my topology. I'll show that in the GUI in a second. Okay, so this is really minimal configuration. Actually, this is not recommended. These two things are not recommended in production. This is really just for my demo. So please don't shut down my demo. This is really just for demonstration purposes, so I don't need to punch in IP numbers. All right. How does it look like on the server side? So this is a configuration that I ran off of JBossAS 6, not milestone 4, but basically a subversion drop as of about 2 months ago. There is a file, there's basically mod cluster is a SAR, which can be placed into the deploy directory. It's an exploded SAR. And to modify it, you have to go to meta-inf mod cluster JBoss beans, and you can modify 2 lines or none. Actually, the first line is important. It tells mod cluster, it tells the JBoss instance where the Apache daemons reside. So here we're saying we have a list of 2 Apache HTTP daemons, HTTP D1 at port 8000 and HTTP D2 at port 8000. Okay, so this is the only thing you basically need. The second property here is the domain. By default, it would be the default domain, so you probably want to change that too, but you don't need to. So the default, in my configuration at least, would be default domain. Note that this line is not really needed if you use mod advertise. Mod advertise sends out multicast pings from the HTTPD side, and if multicast is received by JBoss instances, then the JBoss instances can simply determine where the HTTP daemons reside, and they don't need a static list. But usually that's not the case, so in my demo I'm actually using mod proxy list. Okay, how do we start the JBoss instances? We basically do the same thing as before. We have JBoss 1 through 4, and the first 2 instances are running on a cluster called A, and the second 2 instances are run on a cluster called B. We again separate the multicast addresses, the multicast port, but now we also pass in the domain. So JBoss 1 and 2 are going to run in domain A, and JBoss 3 and 4 in domain B. JBoss 1 and 2 register with HTTPD under domain A, and JBoss 3 and 4 under domain B. And basically, every server registers the web apps it serves, the web apps that are present in its deploy directory. The cool thing here is that the same application doesn't need to be present on all the nodes, and mod cluster will only send requests to nodes which have a given application. Okay. Next slide. Okay, so now people are sending me messages while I'm talking, so I guess I'm going to answer questions at the end. But I heard that there were some problems with sound. I hope that's better. I'm getting a little closer to the mic. Okay, so what can we do here when load increases? Let's say we have a normal cluster on the left side. It's all in the intranet. So we have a bunch of nodes, 4 in domain A. They use an HTTP daemon. And now load increases. Now you want to go to an internet, to a cloud provider, and dynamically fire up 3 additional workers. This would be a different domain potentially. And that's just an example. So here you could simply start 3 additional workers, and they would serve the applications that are placed into their deploy directory. And then basically, the workers on the right side, they could serve an application that's used to browse catalogs. For example, if you're a bookstore, you could use these applications to simply browse a catalog. I think browsing is probably 90% of the activity. And then if a user decides to actually check out, then he would be redirected to the left side, and then, you know, credit card processing and checkout, the whole checkout process would be done on the left side. What's cool about this, as I said before, is domains can have different replication configs, JBoss, JGroups versions, and even different web apps deployed. So the right side, the right cloud, could actually have only the catalog application deployed, whereas the left side could have the checkout, applications deployed. Okay, let's actually switch to the demo now, and then come back and I'll show three more slides. So let me try to share my desktop. This is going to take a few seconds. I hope you can see my my EC2 instances in a second. Yeah, now it's coming up. Okay, so what I've done in the demo, let me actually look at my script so I don't. Okay, what I've done before is I've started an HTTP daemon. I bound it to a address in DNS. We'll have a look at this in a second. And I'm running 2 JBoss instances connected to that HTTP server and forming a cluster. Now I can actually go to the not cluster application and I can take a look. Takes a few seconds until this comes up. So now you can see. This is the equivalent of the /status application on Mod.jk. So this is the location of my manager, Mod Cluster Manager, and I have, as you can see, on the left side I have one domain, the EC2 domain, and it has currently 1 node running. Actually, that's probably wrong. I just did a refresh, so now I have 2 nodes running, as you can see. Under context, you can see the web applications that are deployed. Currently, we have /web/session-demo and /load-demo. And I'm going to go and create a session on session-demo. So let's add some data here. Okay, now I have data in the session, and the session went to 202.149.140, which is the first node in the EC2 domain. All right. Now we want to go to the first node, and I've actually SSH'd into the first node, and you can see, if I grab for Java, you can see that, not yet, but you can see the process. And I'm going to kill this process in a second. But I actually want to go to the second node, the second JBoss node, and this is already here, and show you that the cluster actually exists. It'll take a few seconds. I need to blow this up a little, I guess. This is actually the JMX console, so I'm going to connect to the JMX console and go to the cache. And basically go to the cache instance. This data is exposed via JMX. And look at the members. And you can see that we have a list of 2 members. This is basically a cluster of 2. And now we're going to go to the first instance. We're going to kill -9. My JBoss instance is 1104, so I'm going to kill this. And when I do a refresh on my JBoss instance, on the surviving JBoss instance, you'll see that the list actually went back to 1. It's going to take a few seconds. I did a refresh, and you'll see on the right side that now we only have 1 instance left in the cluster. Of course, the other instance was just crashed. And if we refresh the Mock Cluster Manager application, you'll see that the node that I highlighted actually disappeared. I'll do a refresh. It'll take a few seconds. Actually, I can already see it on my screen. Yes, you can see that there's only 1. And by the way, down here you see the session, so there must have been somebody else who created the session, which is fine. Just go ahead and create sessions. You'll see many more of them. If I now go to my session and do a refresh, you'll see that the IP, it's taken a few seconds to refresh on WebEx, but you see I highlighted the IP address. The IP address actually changed. So did the JVM route, and you can see the data is still here. So what this happened is a very basic functionality. I just showed you that failover of a web session from node 1 to node 2 works. Now I'm going to start my JBoss instance again. And then I'm going to show something else. So we basically showed a failover of a web session, and now we're going to go and disable a context or a web app by basically we're going to go and remove a web application, and this will dynamically be unregistered in Mock Cluster Manager. To do that, we're going to go to which one? We're going to go to 140. To the server directory, and then in its deploy directory. And instead of removing the web application, I'm just going to do a simple move. You can see, hopefully you can see there, I'm moving the session demo war to a session demo war.back. And backs are basically ignored by a scanner, and therefore this application will disappear on the 140 node. So if I click refresh, the session demo here should be gone. It'll take a few seconds through WebEx. You can see the highlighted session demo. I'll do a refresh now, and the session demo is actually gone, as you can see. Now I'm going to move it back, and then it's going to take a few seconds for the scanner to basically scan it. I think it does it every 5 seconds. I'll do a refresh, and you see that the session demo is once again here. This actually happened. This is the second feature of Mock Cluster. It actually happened dynamically. The JBoss instance on which I kind of undeployed and then deployed the context dynamically told all the connected HTTP daemons, in this case only one, that a new application called session demo was actually registered. All right. Now, the difference between undeploying an application and disabling it, and I'm going to show how disabling works in a second, is that an undeployed web application will not have any requests to it immediately. So if you happen to go to a given node for a given web application and the web application is undeployed, then the clients are automatically failed over to one of the remaining nodes, which actually do serve the web application. When you re-enable the web application, the clients are not automatically going to come back. They're going to just stick with the new host, and only if the new host either shuts down or undeploys a web app will the clients fail over to yet another node. Could be the old one or yet a completely new one. Disabling a context or a web application simply means existing clients are going to be able to continue accessing the session, but no new sessions are going to be created on the given node. And then basically when all the sessions have drained, you could actually shut down the node and upgrade it. All right. Now the third part of the demo is I'm going to start a client, a graphical client which accesses the application called load demo. So it's going to go to http://1.dndns.org, port 8000. Then it's going to create 80 threads. This is going to simulate 80 clients. So basically it's going to create 80 clients in 2 minutes. So it creates about a little bit less than a client per second. The session lifetime, let me change it to 30 seconds, is 30 seconds. So that means a client creates a session and then sends requests every 100 milliseconds, so basically 10 requests per second. For 30 seconds, once 30 seconds have elapsed, it's gonna kill the session and create a new one. I click on Start. Oops, there is a problem. Let me actually kill this again. Let me run it again. I punch in the wrong name. Okay. No. File not found exception. This was actually working a few minutes ago. Let me actually see what happens here. Load demo is here. Load demo is here. Okay, this should actually work. Now, why doesn't it work? Give me 1 second. I'm trying to start this again. File not found, load demo record. I hope nobody actually modified the HTTP daemon, as I don't have any privileges set. Well, that might be my problem, but I basically don't have any privileges set. I allow access to both the HTTP server and the JBoss instances from all possible IP or from all possible locations. I hope that nobody actually screwed up my settings. Give me 1 second. I'm going to restart a node here.
The one tip we're getting is that the application is not enabled.
The application should be enabled. No, it should be enabled. I can see that on, let me actually go to the mod cluster. I can see that the load demo is enabled. Oh, no, somebody disabled it here. Could you please, yeah, I see there are, okay, I can see there are a few sessions created here. So please, if you can, I'm going to enable all the context here. I'm going to enable them here. And please refrain from, I know it's tempting, but please do refrain from modifying those. I know I'll probably do it myself, but anyway. So I'll try this again. So now it works. Yeah, this is the hazards of running a live demo. But please don't disable sessions. Anyway, you see that we have a red and a blue curve now, a red and a blue line, and there are 2 hosts that are in the cluster right now in the domain EC2 domain, and they're going to go and create 80 sessions, so 40 sessions per node approximately. And while they're ramping up, I'm going to go and create yet another instance here on EC2. This is going to take a little while. So I'm running a JBoss instance. And so this is going to start up. It's going to take a few minutes. And while it's starting up, I'm also going to create an instance on GoGrid. GoGrid is another cloud which also provides services similar to EC2. So it's an infrastructure as a service. And basically it allows you to create images and run them. And I created a JBoss image here, basically the same image as on EC2, and I'm just going to run it. It also has a list of servers. Let me add a host. Data center is US West 1. That's okay. I'm going to create a cloud server. I created a bunch of images. By the way, the EC2 images are running on Fedora 12, I believe. And here I'm running an image JBoss server, which is based on RHEL 5.4. So this again shows you that, let's give it a public IP address, that it doesn't matter what software, even off the operating system or JBoss, you're using in different domains. This guy is going to go into a domain called GoGrid domain. And now, while we're at it, I'm going to go to Rackspace, which is yet another cloud provider, and I'm going to run 2 instances here. And these guys are going to go to a domain called Rackspace domain. And so we basically have 3 instances in a domain EC2, 1 instance in a domain GoGrid, and 2 instances in a domain Rackspace. Let me start 2 servers. I'm going to add a server. I see that there are a few slides, a few screens behind. Suffice it to say that I'm just creating 2 servers in Rackspace. And this is actually using an image, a private image based on Fedora 13. So we have a mixture of Fedora 12, RHEL 5.4, and Fedora 13 in the same cluster. Let's call it Rackspace 1. Let's give it 4 gigs of memory. I create the server. And then I'm going to create the second one, and then we can actually come back to the demo. So the first server was created. It's being built. Will take a couple of minutes to start. Now I'm starting the second server. Let's call it Rackspace 2. This is also based on Fedora 13. My server images, I pick the image that I created and basically give it a name Rackspace 2. And I create the server. All right, let's go back to the demo. You can see the green line is the 3rd instance that was started on EC2. So now we basically have 3 instances sharing 80 sessions, and you can see on average they have about 25 sessions. It'll take, I think it takes a few seconds to update the WebEx. I cannot see it on my laptop yet. Okay, now you can see it. You can see the green line is the node which just joined, and basically now shares the 80 sessions. So basically the green, the red, and the blue line share 80 sessions, and now on average they have about 25 sessions. All right, now let me show you the last part of the demo. Let me show you how we can disable a web application. We can now see when I refresh the screen we can see that we have 80 sessions. It's going to take a few seconds again. Apologies for that. Seems WebEx hasn't refreshed the screen yet. It'll take a few seconds, and then we should see Mod Cluster Manager, and it would show 80 sessions that we created. And if you look at the routes, you can see that there are different routes. All now we can see the sessions that are created, 80 sessions in total. And what we can do now is we can go to the first node and disable the load demo. We want to disable the load demo. So I just do that. You can see that the screens are lagging behind a little bit. So I disabled the load demo application on host 1. And when I go to the demo, you can see, I think it's the blue or the red line that is going down, close to 0. Actually, it will actually just drain all the sessions and then basically not accept any more new sessions. I still see there's a lag in WebEx, but if it switches within the next couple of seconds, you will see that the red line actually is 0, is flatline. Yeah, you can see it goes down now, and then it actually goes towards 0. Now I can go back and enable the load demo again on this host, and you can see that the red line picks up again. Take a few seconds. Okay, we can also see that, okay, let me wait for a few seconds. Now you can see the red line is picking up sessions again, and now all 3 nodes are actually sharing sessions again. You can also see that Rackspace 1 and 2 and GoGrid haven't yet started. As soon as they start, it will actually take part and grab, or new sessions will also be created on them, and then we see that the total number of sessions per node will go down. All right, let's go back to the demo. Let's go back to the presentation. Taking a few seconds. This is the setup of the demo. One more slide. Okay. All right, this is the setup of the demo. So what do I have here? I have 3 domains: GoGrid, EC2, and Rackspace. GoGrid in this picture has 2 instances. In the demo, I just started 1 instance. EC2 has 3 instances, and Rackspace has 2 instances. Now, each domain here is also a cluster. So if a session is hosted on the second node in the EC2 domain, then it will always go to the EC2 domain. Should the second node crash or leave, then it would go to the third or the first node, and should all 3 nodes crash, then the data for the session would be gone. The top picture here, the top process here is also an AMI image that I ran on EC2. It includes the HTTPD daemon and the gossip router. Gossip router is a JGroups concept that's used as a lookup service to form a cluster. I don't want to go into details, but the nodes in this cluster actually initially ask the gossip router what are the other nodes in the cluster, and then basically they can talk to each other. They only need the gossip router for lookup purposes. Why is this needed? This is needed because we need a global lookup service that's because multicasting is usually not available either in GoGrid, Rackspace, or EC2. We need a global lookup service, and that's what basically gossip router does. Okay, let's take a quick look at the demo. Well, actually, I don't want to switch back to the demo at this point. It's going to take too long. Let me just finish, and then I'll show the demo again, and then we can take questions. All right, so have we solved our two problems now? I think so. Static configuration is done. We do not need workers.properties or URI worker map.properties anymore. We only configure the HTTP daemon once, adding a few modules, adding a handler, and that's it. And then each JBoss instance is started with a list of HTTP daemons, so that JBoss instance knows which HTTP daemons it needs to talk to. Potentially a JBoss JVM route. This is in the demo. This was generated dynamically using a UUID. A JBoss domain. This was hard-coded for EC2. It was called EC2 domain. For GoGrid, it was called GoGrid domain, and for Rackspace, it was called Rackspace domain. Okay, so the workers register themselves dynamically, and so are the web applications registered or unregistered, basically based on when they're deployed or undeployed. Rolling upgrades can be done, yes. It's the same as with ModJK. You shut down an entire domain, you disable the entire domain, let the sessions drain. When no more sessions are available, then basically you shut down the nodes, upgrade them, and restart them. And then they will dynamically register themselves with HTTPD, and the web applications they serve will also be registered. This process is going to be integrated in John, our management console, and so there should be a button by which you can simply disable or basically shut down and drain an entire domain. Of course, there's also going to be functionality to shut down or to start and stop an entire domain. So the conclusion would be a bit of advice here. Partition your clusters. It's never good to have a large flat cluster because of the problems that I described. The best thing here is to use mod cluster and divide the cluster into smaller subclusters, which we call domains. This also helps rolling upgrades, but it also prevents a plethora of other problems. So the general best practices would always be to divide and conquer. Then use mod cluster to dynamically add and remove nodes to and from a cluster, dynamically deploy and undeploy web applications, and provide optimal load information to help HTTPD distribute sessions optimally. The outlook is that we're working on optimizing JBoss to run in the cloud. Especially my task is to optimize JBoss clusters to run very well in the cloud. And this has ramifications all the way down to JGroups. For example, when you start up a node, you don't necessarily know the IP address. What do you do then? What is your bind address? And problems like these, that's stuff we're actually addressing or we actually have already addressed. Eliminate the TCP N-1 problem. That's another issue that we're working on. And then use John and Chopper to start, stop, disable, enable an entire cluster. So basically all the steps that I showed you through Mod Cluster Manager should be available in John. We'll also provide a view of the cluster topology, cluster vitals, stats, all the things you're used to in John. Okay, that's actually my presentations. I would be happy to take questions. I also suggest to take a look at jboss.org/modcluster, download it, try it out yourself. For questions, there's a mailing list that's also Mod Cluster, basically it's Mod Cluster related mailing list where you can ask questions. We're very happy for feedback, and I'd be happy to take questions now.
Well, Bela, thank you very much for that excellent demonstration presentation. We actually have a large number of questions because we have such a huge crowd today. So I actually seen a few recurring themes. One is people want to know where the recordings will be. And so the key answer there is if you look for jboss.org/webinars, where that site we registered at for all our webinars, we will publish the link to the recording at that site. The next most common question is, where can I get the slides? So Bela, is there a place we can publish the slides in the PDF form?
Yes, I can send you the slides, and then you just publish them wherever we need to publish them.
So I can upload them as well to jboss.org/webinars, so we'll have a link to the slides there and the recording. And the last thing that came up several times was, how do I get access to the demo application so I could do some of this testing for myself?
But then, what's the question? How can I access the demo application?
Right, the demo application that you were showing to illustrate,
right,
the WAR file?
Yes, I'm actually going to go back to the demo application now and share my desktop for a second again. I forgot to do that. The demo application is part of Mod Cluster. So if you download Mod Cluster, there's a directory demo, and then a subdirectory client, and this has a script, a shell script, and a bat script to start the client, and then basically that's all you need to do. So it's part of Mod Cluster. By the way, I'm actually showing my desktop again. You can see by now we have a bunch of nodes running. The yellow line, I'm not sure if you can see it, is the GoGrid instance. The purple line is Rackspace 1, and the blue or magenta line actually is Rackspace 2. So I forgot to actually show this at the end of the demo. You can see that we now have 1, 2, 3, 4, 5, 6 nodes, and they're sharing 80 sessions. I mean, they're basically distributing the sessions among themselves, so we have a total of about, or an average of about 12 to 13 sessions per node.
Okay, and while you're sharing,
I'm going to stop.
No, while you're sharing, there was someone who wanted to understand what your configuration was around Mod Cluster, so that it actually did the detection of new hosts joining the cluster automatically. You're
fading. Can you type in the question to a private in the private chat window? What's the question? How are the nodes dynamically registering themselves with HTTPD?
Right.
Oh, okay. Well, there's this. Basically, they're going to port 8000. And Mod Cluster intercepts the request, and there's a slide that I showed where we have a backlink from the node to HTTPD, only a conceptual backlink, but still a backlink, and we have a management protocol called MCMP, Mod Cluster Management Protocol, MCMP, which basically has a few requests that are posted to HTTPD. One of them is an enable, and it basically sends the IP address of the node plus all the applications it serves to HTTPD, and then HTTPD adds them to an internal dispatching table, and when a request for a new session for a given application comes in, it checks all the hosts and basically removes the hosts which don't have the web application, and then basically just picks a random host. Actually, it's not so random, but it picks a host which has the application and then directs the session to that host, and from then on it's all sticky. And when a host dies, it's the other way around. There is a disable for all the web applications, and then there is a disable being a request for the host itself.
Okay. And we do have a large number of questions. We're not going to get a chance to see them all, address them all, so hopefully you guys in the session today will happily put some of those into forums and email lists as we can't get to all of them. But a couple of them I'll just call out here, Bela. One is the gossip router highly available?
Yes. In this demo, no. The demo only has one gossip router there, and it also has only one HTTPD there. But you might as well run multiple gossip routers, and then basically the instances that are starting up would query all of them to get initial membership. So if the first instance is not running, it just goes to the second, third, and so on and so forth. The same goes for HTTP daemons. I only ran one here as well, be running multiple of them. By the way, if you just run on EC2, we have a specialized protocol called S3 ping, which basically uses S3, creating a bucket, and then basically creating a folder under the bucket that's named after the cluster. And then each node in the cluster creates a file in that folder, and that so others can actually come in and do a list. And then basically that's a good way to find other existing instances without having to run a gossip router. In the demo, I had to run the gossip router. Let me actually show you this again because, oh, that's okay. I had to run the gossip router because I wanted to run a cluster, a multi-cluster cluster, if you so wish, among 3 different cloud providers. And that was the only way to actually provide a global lookup service for both EC2, GoGrid, and Rackspace.
Okay. A couple other questions that we'll try to address, so hopefully there's time. So is there support for mount point exclusions like JK unmount in ModJK? Yes.
The mount point exclusions, there is a keyword, I forgot the exact name, but I think it's called excluded contexts, and they're configured in JBoss itself. So, for example, you saw that we did access an application called JMX Console and Web Console, but they weren't shown in Mod Cluster Manager because we excluded them. I think it's just excluded contexts in the JBoss configuration, and here you have a comma-separated list of mount points or contexts that you would like to be excluded.
Okay, and this question has come up a couple of times. It's related to having multiple data centers. It's unclear to me if that's a disaster recovery data center, or it's just purely 2 different data centers, and you want to have a cluster across both. Do you have any strategies or advice as to how that can be set up?
Actually, that's an excellent question. I think data centers are a very good example of where domains make sense. I don't think a domain or a cluster across data centers makes a lot of sense. So if you have a data center in New York and one in San Francisco, and you have a cluster between New York and San Francisco, there's always problems. There's a lot of switches in between that can crash. There's a lot of jitter, delay. Bandwidth might not be very good. So I don't recommend clusters, although I know of customers who are actually doing this. But then again, sometimes they control their own network and so on and so forth. So while in general this is not a good idea, if you have such a setup, you might have domains in New York and domains in San Francisco, and then basically local clusters in San Francisco and New York, which are congruent with the domains. So if you have a domain of 10 nodes in New York, you could make them a cluster of 10 nodes in New York. Might have a second domain in New York as well. So let's say a good setup would be 2 domains in New York, 2 domains in San Francisco, and then a bunch of HTTP daemons which dispatch requests to the 2 domains. By the way, here we have a very good application of the load balancing policy. Let's say during daylight or working hours in New York, you would like most requests to go to New York. You could actually implement a simple load balance policy which says, okay, working hours, give me lower priority or give me higher priority. Basically, forcing or making HTTP dispatch requests to New York during New York's working hours and to San Francisco during San Francisco's working hours. That's a very excellent use case where you can actually write your own load balance policy.
Okay, we've actually gone over for a long period of time, and believe it or not, the questions still keep rolling in. So here's what I plan to do. Bela, if you work with us on this, and I do have one question you can address right at the very end here, but I'd like to gather the questions out of the chat windows and Q&A section, etc. I'm going to save all of those, and I'm going to publish those questions. And Bela, if you don't mind, we could probably take a little shot at answering some of them and then publish that out there in kind of like an FAQ form. That sounds like a good approach to that?
Yep.
Okay. And then so there's another common question if you read through this. People are very curious about where do they get this information from? In other words, does this ship with Apache? Do I download mod cluster separately? What versions do I have to have of Apache, mod cluster, and JBoss? How do I, and so related to all the versions and where do I get all the bits from? The other question is, what do I do around mod.jk to move to this world?
Well, regarding the first question, there's two distributions. If you go to mod cluster on JBoss.org, there's two distributions. One is a full distribution of Apache. I think it's based on 2.2 something. At least it's higher than 2.8. And basically, it comes with everything out of the box. You could just run it. You deploy it in /opt HTTPD and then just run it. Now, I realize a lot of people already have Apache running, and so for those, you can just download a bunch of modules and then just copy them into your module directory and modify httpd.conf. Basically by just adding that little section of code, of configuration code I showed you, and that would be it. In terms of JBoss itself, if you run JBoss 5, there is a SAR that is basically all of mod cluster is a SAR, a service archive, that you need to copy into your deploy directory and then modify one file. That's it. And if you get JBoss 6, then we basically already ship JBoss mod cluster pre-configured in the all configuration. So if you run the all configuration, you're also starting mod cluster.
Okay. Well, again, we're way over by several minutes. So let's go ahead and bring this session to a close. And I do have all your questions recorded here. We're going to gather those up and do our best to answer those in a separate document. Again, keep in mind that this is just one member of our overall webinar series. Today, Bela gave us a great session on clustering and around JBoss application server, and I think the demonstration on EC2 was absolutely excellent. So thank you very much for that, Bela. Great demonstration overall. We will have the recordings available. Again, look for jboss.org/webinars. You'll see links there. And if you follow us on Twitter, you'll get announcements from us based on schedule changes as well as recordings and everything else that becomes available. Do keep in mind, July 21st, we have Manny coming up with InfiniSpan. I think you're going to really enjoy that session as well. And so we have a great lineup, and we're going to get more content as it becomes available. So if you have a specific speaker or a specific topic you'd like to hear from or hear about, please let us know, and we'll get that information out there, and you can just put that into Twitter also. Okay? So thank you very much, Bela.
You're welcome.